We've talked about that you can talk about data with the measures of center, and we said that the measures of center are mean, median, and mode. This is to give you an idea of kind of an overview of the data. We also have measures of spread. Okay, our first measure of spread that we're going to talk about is range. Range is the difference between the maximum and minimum value. So if we were going to look at this data on this dot plot, what is my minimum value? My minimum value is 4 and my maximum value is 11. So the range is 11 minus 4, which is what? 7. Then we have the interquartile range. The interquartile range is the difference between quartile 3 and quartile 1, and we usually use this for box plots more than anything. So my quartile 1, if I look, that is 5, and quartile 3 is 30. So 30 minus 5 is 25. So the measures of spread, again, are range and interquartile range. We're going to talk about some different vocabulary words that we can use to describe graphs. The first thing we have is an outlier. An outlier is a piece of data that doesn't seem to fit with the other data. It's way away from everything else. Okay, this is my outlier. Then we have a gap. A gap is an area on a graph that contains no data. So notice there's a gap right here because there's no data there. We also have cluster, and a cluster is a group of points that lie close together in a graph. So see, it's all clustered right here. And then you have the peak. A peak is a data point that's higher than the values on the other side. So this is where it goes the highest. So if I look over here, I'm right here, this right here, this is my peak because that's the highest point. Over here, if I look right here, this is an outlier. It's over there by itself. So that's my outlier. This right here would be my cluster because it's all clustered together right there. And then right here, there's a big gap right there. So that would be the gap. I'm in love with the shape of you. We're going to talk about the shape of data. Now, one of the things we have is symmetrical data. Symmetrical data is data that is symmetrical when graphed, and the mean and the median are about the same. So if you look at this, you can tell that it's symmetrical because right here on the box plot, it's about the same length right here. These quartiles right here are the same, and I can kind of see it right here where it kind of makes that pretty little like rainbow type thing. So that would be symmetrical. So what if it's not symmetrical? Well, we have where it can be skewed left. Skewed left means data has a tail to the left when graphed. Okay, that means the median is greater than the mean. So what that means is I'm going to have less data on the left. So notice here it's more spread out over here on the box plot because there's less data. So it's going to take up more room because it's spread out. Over here, I have a tail to the left. And even here, this way, it's kind of like a tail going up. That means that it is skewed left. I also have, if it's not skewed left, it's not symmetrical, it could also be skewed right. Skewed right will have a tail to the right when graphed. Okay, so if you look right here, this goes like this, and then it's got that long tail to the right. Here, the whisker is long to the right. Here, most of my data is clustered in the beginning, and down here, it's to the right. What if it's not any of these things? There's also asymmetrical. Asymmetrical would be something like this, where it doesn't have a tail to the right or the left, but it's not in this pretty like little rainbow thing. So it's not symmetrical, but it's not skewed left or skewed right. It's just asymmetrical. So let's look at skewed left and skewed right on dot plots and box plots. First, let's look at dot plots. Notice this right here kind of goes, starts small, goes up, and then goes back down. That is going to be symmetrical. Now, if it's right here, let's say we've got, it goes up, and then all of a sudden we have all of this, and it goes like that. That is going to be skewed right. And that's because of those outliers over there. Looking at this next one, I'm going to have a long tail to the left because of the outliers on the left. So that's going to make that skewed left. So now let's talk about it with box plots. So if I look at this first one is rather symmetrical. And again, that's because these are the same. Also, the whiskers are the same length. So that's going to make it more symmetrical. Then the next one, I see that right here, that long tail to the right means that it is skewed right. And then this next one, the long tail is on the left, so that means that it is skewed left. So that's kind of how you can tell if it's skewed, and a lot of times that's caused by the outliers.